In this video, we are going to discuss three name reactions: KOLBE'S reactions, RIMER-TIEMANN reactions, and Williamson's synthesis. So first, we'll start with KOLBE'S reaction. Now, KOLBE'S reaction is actually the preparations of salicylic acid. Okay. Now, how it is prepared is like sodium phenoxide. Okay, it is heated with carbon dioxide at 400 Kelvin temperature and under 4 to 7 atmospheric pressure. Okay, then sodium salicylate is formed as major product. Now this sodium salicylate on acidification gives salicylic acid as a product. So sodium phenoxide. So when H gets replaced by O. Now how we are going to get this is like whenever phenol is treated with sodium metal or sodium hydroxide, okay, then what happen is sodium will displace hydrogen. So this since this phenol is acidic in nature, okay, so you'll get on treatment with sodium hydroxide, it will give salt which is sodium phenoxide. Okay, sodium. Now so this on heating with carbon dioxide and temperature 400 Kelvin and pressure 4 to 7 atmosphere. Okay, then what happen is we'll get sodium salicylate. Okay, and this upon hydrolysis will give salicylic acid. Okay, this one is salicylic acid, and what is its IUPAC name? So this one will get the preference. So 1,2 hydroxy, okay, benzoic acid. So common name is salicylic acid and its IUPAC name is 2-hydroxy benzoic acid. Again, what happens in KOLBE'S reaction is like, okay, sodium phenoxide on heating with carbon dioxide at temperature 400 Kelvin, pressure 4 to 7 atmosphere. Okay, it give sodium salicylate. Okay, and this upon hydrolysis give salicylic acid as a product. Now this is your ortho isomer. Okay, so para isomer will also form, but at very low concentration or low amount. So your salicylic acid will be in major amount, and this reaction is what called KOLBE'S reaction. Now let us briefly see what is the mechanism that is taking place and giving you the product, though it's not important according to your examination, but this information you need when you go for the higher studies. Okay, now so actually here your attacking of your carbon dioxide will take place on highly activated phenoxide ion. So we know that phenol, okay, on treatment with sodium hydroxide will get is phenoxide ion, isn't it? So this is your phenoxide ion. So this will carry positive charge. This have lone pairs, right? So you know the resonating structure. So you have done this in 11 ma gareko cha resonating structure. Phenoxide ion ko phenol ko you know very well, hai na? What happen is like your phenoxide, right? Carbon. Now here oxygen is more electronegative, so oxygen le lanja, it will pull electron toward itself. So this one will become now partial positive, this one will become now partial negative. Okay, अब चाहिँ के हुँदैछ भन्दा now यता के हुँदैछ, so positive charge लाई neutralize गर्नुको लागि now यहाँ again phenoxide मा, so this oxygen will pull its electron pair towards the benzene ring. Okay, and यो इलेक्ट्रोन जैसे कार्बन को भ्यालेन्सी कति हुन्छ 4 हुन्छ maximum, right? So यता अझै एउटा आयो भने 1 2 3 4 with this 5 हुन्छ, which is not possible. So यो bond गएर now it will form bond with this carbon atom which have your positive charge. Okay, so के हुन्छ भन्दाखेरि your O now electron dio, right? Now it will have your now positive charge. So sodium is there, sodium no लेख्दा नि हुन्छ, okay? Then के भयो तिम्रो you have hydrogen here र यहाँ तिम्रो को आयो कार्बन सँग bond form गरेको छ हाइड्रोजन कहाँ भन्दाखेरि one hydrogen is here, okay? So कार्बन सँग bond बनायो. Now so this carbon यो oxygen को electron माथि गएको छ, so O negative, right? And it is your double bond. This sodium यहाँ जुन चाहिँ Na छ it will come here because now it have negative charge. ठिकै छ. Now यता के छ भन्दाखेरि now this O मा के हुन्छ भन्दाखेरि so again so this O have now positive charge which is not possible as because oxygen is highly electronegative, right? Again this electron यसले तान्छ लान्छ यसले electron. Now यता के हुँदैछ तिम्रो भन्दाखेरि it carbon को now तीनटा हुँदैछ एउटा गयो तीनटा हुँदैछ which is again not possible. Now यो जुन चाहिँ छ यो hydrogen and carbon को bond break हुन्छ and it will form, okay, bond with this carbon. Now there will be a carbon carbon double bond. Now what we can say is like here timro hydrogen, so there take place a hydrogen shift. यो जुन चाहिँ hydrogen छ H plus, okay? Now timro shift हुन्छ कहाँदेखि from one carbon 1 देखि लिएर oxygen, so 1 2 3, okay? So we can call this as 1 3 hydrogen shift. So simply I'll write hydrogen shift हुन्छ, okay? Kandekhi from this carbon to this oxygen, then what you are going to get is like timro ke cha oxygen, okay? Aba ayo timro hydrogen, haina? Then now eta ke cha, so you bond you there's like there's no more bond between hydrogen and this carbon. Now single bond थियो, now we'll have double bond here. Aru bond ma there is not much change, ke bhako chaina, so it will remain as it is, okay? And again this benzene ring is attached to this group, so CWO then ONA. Okay, this is your sodium salicylate and this upon hydrolysis, okay, give के गर्छ just Na लाई replace गरिदिन्छ H ले, okay? On hydrolysis Na will get replaced by hydrogen, so you will get is OH, C double bonded OOH. ठीक है sir? So this is your salicylic acid. Again के हुन्छ भयो, so the your phenoxide ion, okay? So we'll get attacked by your carbonyl carbon, this carbon dioxide. Kasari bhanda carbon dioxide, you know this is the structure, right? Linear one, and oxygen being more electronegative than carbon, it will pull electron toward itself, okay? This one will become partial positive. Now यो जुन चाहिँ electron यो छ हैन यसले के गर्छ यो जुन चाहिँ oxygen छ, now lone pair it have, so यसले के गर्छ push its electron towards the benzene ring हैन more electron यता के गर्नु negativeness बढाउनुको लागि. And then के हुन्छ भन्दाखेरि so this now ortho carbon will form bond with this carbon dioxide, यो पाउँछ तिमीले, okay? Now what happened here is like you will get this into this species. Now this in this species what happened is like your hydrogen shift will take place from this carbon 1 to oxygen, carbon 1 to this oxygen, okay? त्यसले गर्दाखेरि you will get is again sodium, okay, salicylate, and this upon hydrolysis will give salicylic acid. Though your this mechanism is not much important, okay, according to your board examinations, so but this is needed when you do go for the higher studies. Again Kolbe's reaction, very simple one. Your sodium phenoxide heat garcha with carbon dioxide, temperature 400 Kelvin, pressure 4 to 7 atmosphere, sodium salicylate will form, okay? And this upon hydrolysis will give salicylic acid, and the major product is their ortho 1, okay? Para pani pauncha, but in minor amount. But if we increase the temperature above 400 or 410 degree, that time timarko para isomer, okay, will be in major amount. So this is all about Kolbe's. Now next we'll move to RIMER-TIEMANN reaction. In RIMER-TIEMANN, what happened? So phenol, Okay, it is refluxed with chloroform CHCl3 in presence of sodium hydroxide, okay, at 340 Kelvin, followed by hydrolysis. What happened? An aldehydic group CHO gets introduced in ring at a position ortho to the phenolic group. Okay, orthohydroxybenzyaldehyde or salicylaldehyde is formed as the major product of reaction. So you know very well, just we discussed salicylaldehyde, salicylic acid. Okay, now salicylaldehyde is there, again OH, and at ortho you'll get is CHO. So this is your formylation of phenol, we can call it. Okay, your formyl group will add up to the benzene ring. Again, so you're in Reimer-Tiemann reaction, okay, your phenol, okay, phenol, this phenol is refluxed with your with chloroform, formula is CHCl3, okay, then aqueous sodium hydroxide is there, है ना, temperature कति बंदैछ 340 Kelvin. Okay, then this one will first give very highly unstable species, okay, and that one is dichloromethyl substituted phenol. Okay, dichloromethyl substituted phenol. Okay, so this upon further reaction with the sodium hydroxide will get is sodium salicylaldehyde. Okay, and this upon hydrolysis, what happened, this Na will get replaced by H, then you'll get is OH CHO. So this is salicylaldehyde. Okay, it's this one is its common name, and what is its IUPAC name? Again CHO and OH. Okay, so again CHO will get preference, so 1 then 2, so its IUPAC name is 2-hydroxy benzyl dehyde. Okay, so again, so what is Reimer-Tiemann reaction? So Reimer-Tiemann reaction, your phenol, okay, is refluxed with chloroform, aqueous sodium hydroxide at 340 Kelvin will get is very unstable species, methylated dichloromethyl, okay, substituted phenol. Then this upon again reaction with sodium hydroxide will give sodium salicylaldehyde, and this upon hydrolysis gave salicylic acid 2-hydroxy benzaldehyde. Again, in this case also para isomer, okay, will also form, but in minor amount, and you will get salicylaldehyde as major product. Okay, so Reimer-Tiemann reaction, preparation for salicylaldehyde 2-hydroxybenzaldehyde, and KOLBE'S reaction, preparation of salicylic acid 2-hydroxybenzoic acid. Now, last reaction that we are going to discuss in this video is Williamson's synthesis. Okay. Now, in this method, alkyl halide, what is the formula? Alkyl for R, halide X. Okay. And it is treated with sodium alkoxide or sodium phenoxide. So, whenever your alcohol, you know what is alcohol? ROH. When this H get replaced by Na, so RONA, sodium alkoxide, okay, alcohol को H लाई Na ले replace गरे नि, you'll get alkoxide, and formula is RONA, or phenoxide, you know phenoxide, right, benzene ring ONA. So whenever the two are treated, what happen is like you'll get is symmetrical or unsymmetrical. It depends on whether you have same type of alkyl group on in this alkyl halide or this sodium alkoxide. Okay, now what happened here, Na and X will removed as NaX. भयो. So यो Na र X remove हुन्छ as NaX रह्यो को R then O bond जहाँ break हुन्छ त्यही नयाँ bond form हुन्छ. Here the bond is breaking between RO Na, right? So O ले नयाँ bond form गर्छ with this R. So you will get is ROR. This is your ether. Okay, if to the either side of oxygen, if you have both the alkyl group, one alkyl, one aryl, so it's your ether. It is ether. Now let us do some examples. Any alkyl halide, let us take methyl chloride, okay, and your oxide like this alkoxide ma, let's take R as again CH3, then O, then Na. Now what happened? Your Na and Cl will removed as NaCl. Now के रह्यो? CH3 then O. Okay, every time write your alkyl group with oxygen first, हैन? त्यहाँदेखि रह्यो अर्को CH3. You will get is this is symmetrical ether. Why symmetrical? Because either side of oxygen contains same type of alkyl group. Same alkyl group छ भने यसलाई भन्छ symmetrical, okay, ethers. Ether. Now what is its name? So हामीले गरेको छ, either we can call it as dimethyl ether or methoxymethane भन्नु पनि सक्छ. Okay, so this is your methoxymethane. हैन? So let us take some more example. Again, Williamson's synthesis, your alkyl group, alkyl halide, reaction with alkyl alkoxide. So let's take this alkoxide. Okay, what happen is NaCl will removed as NaCl. Rayoko, first write down your alkoxide, हैन, को your this one CH2O, okay, alkoxide, then your methyl group, it is your CH3. Again, let us take some more example. Third one, CH3Cl plus, this is your phenoxide. This is phenoxide, right? So phenoxide, again, what happened? Na and Cl will removed as NaCl. हैन? पहिला your phenoxide लेख, phenoxide, okay, and then you make new bond with this CH3. So this is your product. Now, if you have CH3, CH2, CH3, Cl, and CH3, CH2, okay, ONA. Now, what is the product? Okay, so, okay, we'll take is this one, okay, CH3, CH2, CH3, then CH2Cl. And this alkoxide, what happened again? NaCl will removed as NaCl. Okay, then hamroमा के छ? First write down this alkoxide CH3 CH2O. Then now see here the bond is broken between your CH2 and Cl. Okay, now this same CH2 will form bond with O. So then this CH2, then your CH, this CH, okay, then CH3, CH3. So these are the product during Williamson synthesis. You will get symmetrical one, you get unsymmetrical ether. However, there are some limitations of this Williamson synthesis. Okay, so whenever we are preparing ether using this Williamson synthesis, then the alkyl halide, okay, it should be primary one. So alkyl halide, preferably it should be primary, 1 degree, okay, primary halide. Whereas if we take a secondary or a tertiary, so which is generally denoted by 2 degree or 3 degree halide, alkyl halide, then what happen is instead of getting ether as a product, we'll get alkene as a product. Okay, so okay, भने मैले 1 degree halide. Okay, what is 1 degree halide? So if your halogen, okay, यो जुन चाहिँ carbon छ, so the carbon which is directly attached to that halide, Okay, if that contain 2 hydrogen, दुईटा hydrogen छ भने यसलाई 1 degree भन्छ. If the carbon attached to your halide, any halide, okay, if it contain only 1 hydrogen, this is secondary, okay, halide. And halide with no hydrogen, okay, if your carbon which is attached to any hydrogen, okay, if that carbon do not contain any hydrogen, so this is your tertiary one. So बुझ्नु पर्यो प्राइमरी मा के हुन्छ, कार्बन हाइलाइटसँग अट्याच भएको कार्बनकोमा 2टा हाइड्रोजन हुन्छ या 3टा हुन्छ, ओके. एन्ड तिम्रो एउटा भयो भने द्याट इज सेकेन्डरी, and 3 degree भयो भने tertiary. र विलियमसन सिन्थेसिसमा whenever we are doing the reaction, so the preferred alkyl halide to be chosen is like your primary one. किन भन्दाखेरि now what will happen in विलियमसन synthesis, जस्तै तिम्रो R is there, okay, O, Na, then if you are using R, X, then what happen is, you know, this halide, it is more electronegative, it will pull electron toward itself, it will have partial negative charge, then alkyl will have partial positive charge. Okay, now oxygen means lone pair cha, it's a electronegative, right? Now यसले के गर्छ, न्युक्लियोफिलिक अट्याक गर्छ. सो न्युक्लियोफिलिक मिन्स योर नेगेटिभ चार्ज या लोन पेयर भएको कुनै पनि स्पिसिसले अट्याक गर्दछ योर कार्बन एटमलाई, द्याट इज यो न्युक्लियोफिलिक. सो दिस वी आर गोइङ टु डिस्कस, ओके. एन्ड न्युक्लियोफिलिक अट्याक, सो नेगेटिभ, सो देन यु विल गेट इज R, then you will attack गर्छ, then this all will leave, okay, as halide ion. So you will get is R, O, then R, okay, and your Na पनि जान्छ, X पनि जान्छ, then you will get is NaX. So this is what happening in the reaction. So your nucleophile भयो, okay, so तिम्रो R, X now nucleophile ले attack गर्यो र गयो, so you will get is nucleophile and R and X निस्केर जान्छ. Okay, so this is what called nucleophilic substitution reaction. So Williamson synthesis nucleophilic substitution reaction हो भयो. So primary लियो भने nucleophilic substitution हुन्छ, but when you take secondary and tertiary one, then अब के हुन्छ भन्दा elimination reaction ले के गर्छ, competition elimination and or elimination र substitution reaction मा के हुन्छ, competition हुन्छ. Suppose हामीले now if you have your tertiary, so this is tertiary one. Why? It contain no hydrogen, this carbon contain no hydrogen, this is tertiary. Okay, now suppose what we are using here is like your alcohol oxide, right? Now you जुन चाहिँ alcohol oxide छ, okay, so it will like act as a nucleophiles, your nucleophile जस्तो काम गर्छ. So when your primary halide is present, okay, 1 degree halide is present, nucleophile जस्तो काम गर्छ, and it will also act as strong base when your alkyl halide is 3 degree tertiary. Strong base, अब base ले के गर्छ भन्दाखेरि it will abstract proton, proton थाप्छ, okay न. Base like acid भनेको के हो, प्रोटोन डोनर हो, बेस भनेको के हो, प्रोटोन एक्सेप्टर हो. अब यसले के गर्छ भन्दाखेरि यो कार्बन, ओके, दिस वान इज अल्फा, कुनै पनि ग्रुप तिम्रो कार्बनमा अट्याच छ भने अल्फा हो, एन्ड त्यसको नेक्स्ट all are beta. So यो पनि बीटा, यो पनि बीटा, all beta. भाइ त्यसको इमिडिएट नेक्स्ट कार्बन बीटा, त्यसको नेक्स्ट कार्बन गामा, त्यसरी हुन्छ. सो अगेन विल कम टु दिस पोइन्ट, हामी घरि आइबस्छ, सो तिमीलाई बादमा याद भइहाल्छ, प्रब्लम छैन. ओके ओके, नाउ के भयो, के गर्छ, स्ट्रङ बेस मिन्स प्रोटोन लान्छ. सो प्रोटोन अब कहाँबाट लान्छ, बीटा कार्बनबाट. ओके, अब बीटा कार्बनबाट लग्यो, एउटा सबैबाट होइन, एउटाबाट लान्छ. सो CH3 देन Cl, ओके, यसले एब्स्ट्र्याक्ट गर्यो. सो दिस वान विल एक्ट एज अ स्ट्रङ बेस. सो पहिला तीनटा थियो, अब कतिवटा हुन्छ, दुईटा हुन्छ. प्रोटोन मिन्स H+ लगेर गयो, अब 1 नेगेटिभ चार्ज तिम्रो यो मिथाइल ग्रुपमै बस्छ. ओके, नाउ दिस मिथाइल ग्रुपले इलेक्ट्रोन पुश गर्छ टुवर्ड्स यो दिस कार्बन, र 5वटा कहिले पनि बन्ड हुँदैन. सो दिस Cl इज मोर लाइक लिभिङ ग्रुप होइन, किनभने बन्ड इज भेरी विक, पोलार छ. सो Cl विल लिभ. Okay, and what you are going to get, यो कार्बन भयो दुईजनाकोमा बन्ड छैन नाउ CH3 यो CH3 as it is छ okay now this carbon and this carbon now have double bond हैन CH2 so what is this product called this is not ether though you have taken alkyl halide okay you have taken alco oxide okay but you are not getting ether what you are getting is alkene so त्यसले गर्दा limitations are there for Williamson synthesis okay so every time in order to prepare ether primary alkyl halide is preferred over secondary and tertiary why because secondary when we take secondary tertiary halide that time के हुन्छ रे न्यूक्लियोफिलिक सब्स्टिट्युसन एन्ड एलिमिनेसन रियाक्सनको बीचमा कम्पिटिसन हुन्छ okay so in secondary you will get mixture of alkene okay and ether secondary मा and the tertiary मा के हुन्छ you will get only alkene tertiary ma you will get only alkene you will not get any ether as a product किन भन्दाखेरि यता प्योरली के हुन्छ तिम्रो सब्स्टिट्युसन रियाक्सन will occur किन because alkoxide so it sometimes act as a strong nucleophile sometimes it act as a strong base depends which halide you are using you are taking okay so this is one of the limitation of this Williamson synthesis and next one is again alkyl halide हैन aryl halide okay so halide and like this we cannot take okay like in order to prepare your ether हैन so diphenyl ether if you want to prepare so यो हामीले लिनु सक्दैन why the reaction will not occur किन भन्दाखेरि so again this one will come across with this question the reasoning question मा आउँछ तिमीहरुको यो okay किन भन्दाखेरि now the bond between the two is like partially double bond okay so this carbon is sp2 hybridized and the like जुन चाहिँ sp2 hybridized carbon is more electronegative so त्यसले गर्दा it will pull electron toward itself यसले पनि तान्नु थाल्छ र partial double bond so resonating structure draw गर्दाखेरि पनि okay you will find that the bond between this carbon and halogen is partially double bond and because of that it is very difficult to break this bond okay so that means तिम्रो जति पनि aryl halide छ it will not take part in any nucleophilic substitution reaction okay यो question आउँछ तिमीहरुको okay so resonating structure to draw resonating structure is very important so practice gara one time two time okay now halogen so with your lone pair so one lone pair आयो okay then के हुन्छ यो bond यहाँ आउँछ then this bond will go to this carbon bond okay what you are going to get is like यो X र carbon को बीचमा double bond भयो यो bond कहाँ आएको छ okay to this carbon let's say यो carbon मा आएको छ so here negative charge will reside and again this negative charge will go to the bond and this bond will go to this carbon atom as negative charge so तिमीहरुको पाउँछ double X plus then यहाँ के छ यो bond यता आयो यो electron यो जुन चाहिँ छ यहाँ छ double bond okay now this bond will reside here at this carbon atom again यो bond यो electron जान्छ यहाँ and this bond will become electron here lone यता negative charge okay X plus so यहाँ तिम्रो negative charge आयो then this negative charge from here will come here as bond अर्को यो bond केही भएको छैन it is as it is like no change so यहाँ आयो with to this carbon again your bond this halogen will pull toward itself now again you will come to the original हैन like structure so X with your single bond so now you can see in structure 2 resonating structure 3 and 4 okay so there is partial double bond between your halogen and carbon and because of this Okay, so this is highly like it is non-reactive in case of nucleophilic substitution reaction. Okay, sir. So you again this will come this type of question again will have to do in reasoning question. Thank you.